Continue our track, and now we're switching to Valentina from Security Vision. She's going to share a story with us about the search of the ML algorithm to search for anomalies in network traffic. Would you please welcome Valentina Pugacheva? Hi. Hello, everyone. Our purpose was to detect anomalies in network traffic, which could not be determined and identified with classic method based on our knowledge of the typical behavior, like correlation rule, whitelists, etc. As well as that, we wanted to detect anomalies. Apart from that, we wanted to detect anomalies in real time and big flow. And as a source of data, we considered network traffic events. So the information was sent about the data sent about from the source to a recipient, gathered by some kind of a network device, a proxy server, a CM system, any device. And as far as the non-typical event, anomalies were considered the events which were different from the main flow of the events with the combination of the features. And we wanted to group the events as well to incidents, security incidents, so that our people would not be attacked by a bunch of incidents. That's why clusterization was used, which I'm going to elaborate a little bit later. If it was closed as false positive, I mean the incident, we wanted to take that feedback into account in order to prevent such events from occurring in the future, from recurring in the future, rather. And we chose machine learning methods because our purpose was to detect non-typical behavior, which would be described as abnormal behavior. Traffic would change with time, so we needed a system which would automatically adapt to such changes. Machine learning suited as well, thanks to its learning capabilities. And we had some limitation set due to the specific features we set and due to specifics of the implementation into the customer's infrastructure. We didn't have sufficient data about all of the anomalies and all possible attacks, of course. So that's why we were dealing with the non-marked data. We didn't really know about those events, whether those were normal events or anomalies. So we had to learn without the teacher. We didn't have any expert assumption of the anomaly to occur, which also complicated the situation. So what we needed was to process the events in real time. The flow was kind of huge, dozens of thousands of messages per second, and we would have to analyze the number of false positives. Traffic would change over time, and we had to update the model using the data constantly. We did have different types of sources of data, and we wanted to develop a universal solution which would take raw data from any device. So we kind of limited with the number of features we could take, because we identified that different devices would give us different identifications, IP protocol, and others on which we based our models. So we also had some limitations due to computing resources. We had a big virtual machine, a bit of RAM, and we didn't have a very powerful CPU, a 12-core CPU, so which did influence our choice of methods quite seriously. So in this work, we tried and tested a number of methods of learning without teachers, so we would have to use it with the non-marked data, and such methods, as it's believed, considered to be targeted at looking for new data, and different ML methods tackle these two tasks in different ways. So we tried a set of methods. We used clusterization, isolation forest, local outlier factor. I wouldn't want to stop at local outlier factor. This method did not suit us because it requires quite a lot of computing resources and it was not fast enough for our task. And in this work, we decided not to use neural networks, also because of the limitations of the computing resources, and it would take much more time to make the neural networks learn, to teach them, so it would take quite a lot of time. In the course of the experiments, we ended up with a solution which would take a flow of events from different formats. It would normalize them into the single flow. Then we would filter the features and we aggregated. And we had to see the increase of performance. We doubled it or even multiplied it by 10 times, depending on the types of data we received. And then we conducted pre-processing. And the batched data would be sent to look for deviations, and such deviations would be detected, and such incidents would be registered in the source system of the customer. We would save and accumulate our data into a specific batch and would train the models. Would normally train the models at least once a day. Because if you do not do that, this model becomes obsolete and starts generating too many false positives and misses anomalies. A few words about the methods we tried. The first method we tried was clusterization. So there are a few ways of using it. The first and the simplest one is to look for centroids of data and measure the distance to centroid, identify the threshold, and decide whether it's an anomaly or a normal event. This method is fast, but it ends up with some rough results. So we'd have to identify the thresholds with some experts, knowledge, expertise. We didn't have it, so we did not want to develop that method. Instead, we used another one, clusterization. We singled out small clusters, and the remaining small events and smallest clusters also would turn out to be anomalies. K-means and db-scan methods were applied here, and both of them have their pros and cons. One of them being very popular, it's fast, it clusters the points. We can select parameters in proper way once, and these parameters do not affect the tasks. You don't need to make manual adjustments for that. You don't need to use human for that, but this method is not fast enough. And the next method, K-means, was fast, but its disadvantage was that we'd have to know the number of clusters beforehand, and you would have to identify it again at each next batch. So an automatic procedure was required, which slows down that method and reduced its efficiency. That's why we decided to use isolation forest. This algorithm is based upon trees, and it isolates each point and identifies normal points and anomalies. It was very easy to isolate the point, and it stands out far away from the main number of points, and it is marked as anomaly. If it's very hard to isolate and if it's surrounded by other points, the algorithm believes that it's a normal point. The pluses for this algorithm was its speed and the ability to process a big flow of events, and at the same time it's a plus and minus. Isolation forest does not require preliminary training, so they are singled out inside the batch. But if the flow of events is very dense, this batch does not turn out to be very representative, even in the course of the hourly traffic, to say the least about daily traffic. We can, of course, increase the sizes of batches, but thus it will lead to a bigger time to get the results. Or you can mix these to the batches, but it will also slow down the algorithm performance. One more difficulty, when we use this algorithm, we would have to identify the contamination parameter, the contamination of data, which was the expert assumption of the abnormal data, which we didn't have. How we decide that? We fix that contamination parameter. Isolation forest allows us to get the weight of normality of the event. We measured and calculated the normality weight for each event, made up a histogram and identified thresholds. Thus, we needed to minimize the flow of anomalies and incidents. Thus, we could select non-typical events and manage them. Once we selected that threshold for each event, we would identify the normality weight, and with the use of isolation forest, would identify whether that was a normal or abnormal event. We used more than 10,000 events per second data flow, and we used it for a course of a few weeks, and the processing of one single batch took less than a minute. One batch would contain thousands of events. We used a few flows to cope with all of the event flows, and after carrying out a few experiments, we managed to get up to 20 incidents per week, 10 to 20 incidents per week. Half of them turned out to be compound complicated positives, but most of them were legitimate rare events or legitimate scans which would be carried out every fortnight. Thus, we detected them. All the other events would be split into infrastructure incidents and the real incident events. The next method was one class SVM, which is a form of a classic SVM with one class of events, normal events. We separate the events into normal and abnormal. Thus, the non-linear correlation is built up. The advantage of this algorithm is that it allows to make up a boundary, and it is suitable for learning. This prediction method works quite fast, but its feature is that it requires training. So the better, the cleaner our selection for learning, the better the final result will be. Since this traffic is not static, this algorithm needs to be retrained on a regular basis. We decided to retrain this algorithm once a day, and that was enough. And I also wanted to say just one funny bit. This used metric of distance, so it uses the categories, the addresses, the source, the recipient were used here, and we use different types of coding. Simple linear turning of the address into number did not suit us well, because the addresses as numbers were neighboring ones, and the algorithms were also similar, but they could be different servers. They could be different servers which had different profiles. So ultimately we ended up having this frequency coding. Just like isolation forest, we tested it with the use of real data, the flow of events, and we did it for a few weeks, and the processing of one single batch took approximately a minute, and it occurred as a process. We trained this model once a day, and we gathered that for 7 days to take into account the cyclical traffic per week. Would normally get approximately 10 incidents per week, with a normal split into false positives and the real incidents. And in this case, we identified non-typical events, just like isolation forest, and we identified new events, just like the beginning of scanning, which we saw more completely rather than with the use of isolation forest. Before this, scanning was included into the training batch. As a false positive example, we can show you the following thing. The customer would have legitimate scans for vulnerabilities and backups, which were carried out more rarely than once a week. Then we closed them as false positives, and we took that feedback into account, and we no longer measured them as anomalies afterwards. We detected quite a number of such scans, so we decided to put it into a separate task, which was solved in classic fashion. We thought that the flow, the traffic flow, and the number of connections between two nodes are distributed properly, so we introduced this normality threshold by use of the 3 sigma rule. We gathered the data by days and would put the threshold. Then we analyzed the events, and we accumulated the volume between these couples, the source and the recipient. As soon as we saw the exceeding of the threshold, we marked those events as deviations. After we selected the non-typical events algorithms division, we had to group the anomalies before we took them as incidents of information security. So for this, we used clusterization, k-means and db-scan, which I mentioned previously. K-means we used as a spare one when we saw that db-scan could not handle most of the events. We started with simple clusterization of all of the anomalies, and we resulted with very rough clusters, and we could not just join them together that easily. So we removed all of the other features but addresses, and we clustered around addresses, addresses of the source, addresses of the recipient, so we could more conveniently group these events, and it helped us investigate them much more easily. We developed an integrated solution which works with different sources of data, accumulates the events, and interacts with the customer's ERP. We tested it with the workload, and generated the appropriate number of incidents and appropriate number of false positives. We try to use this machine learning with different types of objects in the network traffic, like the authorization events, Linux and Windows systems, the launch of processes, etc. Thank you very much. Yes, you can ask questions. Please use microphones for questions, and the best questions will be awarded with T-shirts. I'm Alexander Konkov from YouMoney. You didn't say any numbers about the precision. I mean, in percent, how much were there false positives in percent? At the Black Hat conference in 2018, Japanese network engineers coped with the same task. They took firewalls logs and proxy logs and accumulated similar data. And they did it in the very original dual matrix pictures, and they put these pictures into neural networks, and 96, 98 correct detections of anomalies resulted. What are your numbers in percent, and what types of network anomalies did you manage to detect? So, how complete were you? Thank you for your question. We did not measure such things because we did not have marked data. And the actual idea was that it was zero knowledge. There was no knowledge about that. We didn't get it marked either. In different days it was different, but normally we would get approximately 50% of false positives. The precision was measured at the experiment stage. We added anomalies manually, and we made sure that such anomalies were detected 100%. Well, what was happening ultimately after a month? Well, during the month, we would be getting approximately 10 incidents, grouped deviations, measured against what? Number of processed events. Approximately 1 billion events per day, per 24 hours. Thank you. I'm Anastasia Gurina from Infotex. I have a question. Is my understanding correct about network traffic? Did you try to measure how frequently the traffic changes in the corporate network? You said that you changed the training of the models very regularly, like every day. Thank you for your question. We trained the model, we launched it, and it turned out that very soon, in a day, it started generated a lot of anomalies. We started dealing with it, and seems like that selection was not suitable for the behavior for the next day. Was it just a session you took for an event? Right. And how did you digitize the events? What was the size of the characteristics? Not for specific attacks, but everything that you could digitize, you digitized. Exactly. We wanted to get the general algorithm which would take a look at the traffic generally. How many did you have? Well, addresses, ports, bytes, sent, and protocol. Those were the features that we used. Thank you. Nikita Kurganov from Yandex. Here's a question. Well, it's clear about anomalies, but what kind of anomalies? Scanning was used there. For example, a server was breached, you got a reverse shell, you started a payload analysis. Can your machine learning be tried at such cases? Did you try such things? Thank you for your question. We did not try such specific cases for testing. In theory, if such event did happen, from that server would be having a non-standard interaction. So the model would have to notice that. We identified non-standard addressing from inside to outside, and such things were detected. Hello, Dmitry Chesnakov from Sberbank. You said that this model was retrained once a day with data for a week, and how did you cope with the problem of the production interrupts? For example, you have a holiday week in May. Before holiday week in May, you didn't have any interrupts, and then you started having a lot of anomalies afterwards, after the holidays. Well, we would like to expand that in the future. Such things you described do not occur very frequently, so we decided to postpone the resolution of the mentioned problem for a later time. Hello, thank you for your report. I'm Vladimir. What was the flow? 10,000 events per second. What kind of network traffic does it match with? And how did you measure the anomalies? For example, there was the first picture of yours with the events generated. Okay, let me see. Let me identify your question more precisely. You're talking about this slide of yours. I'm not sure whether I understood your question. I think the question was quite unclear. And he's trying to clarify, but he's not speaking into the microphone. He's clarified it off the mic, and she's answering. We took the logs, which would record the information about all of the interactions. We did not attach to the rules. We logged all of the network interactions and how many gigabits of traffic it took. Unfortunately, I don't have any such information at all. We did not measure that. I'm Dmitry Murin from Yaroslav University. I have a couple of questions to you. The first question, when you were training the model, how was this system working and how many false positives were you measuring during the training time? And the second question, you were using the proper allocation, but in many cases you saw that this distribution by cache, and can you really use this normal distribution in all situations, really? Well, let me just try to answer the second half of your question. As far as the statistics model is concerned, we took it as an additional model, so it was possible to take this rough assumption. We did not have too many inputs, and we did not invest much into the model. And we have quite a number of solutions available, and we didn't really want to make them any better. We just wanted to let our machine learning systems breathe a little bit better. While the model is retrained, the trained model is already working. So we don't have any pauses in work. And as far as the very first launch is concerned, when we did not quite select the data, well, actually, the more data we select, the more precise the results will be, a few hours at least. And for first At first, the flow of false positives will be more, of course. So I have a suggestion then. When your threshold initiates, you start getting false positives, you immediately get into the switch to the model which is already working and is working in parallel, and you switch to this model at this moment in time. Good, thank you. I'm from Sberbank, and you said that this model trains and retrains. Did you automate that, and what means did you use that? And how did you? What kind of business effect did you achieve with that? So less alarms, more free time for admins, etc. What was the practical effect, and how was it measured? Thank you for your question. Well, people started maybe sleeping more or maybe sleeping less. I don't know for sure. We tried these models for a month. Each of the models were tried for a month. I'm not sure whether these models are working properly and admins are sleeping peacefully. We are considering these solutions as a solution which makes life a little bit easier for the people, but I wouldn't want to claim that we have found a universal solution to all of the problems. It's not such a solution. As for training, I'm sorry, could you please repeat that part of your question so that So the automatic training of the model, and how does it get into prompt? It is done automatically. A separate process is launched which retrains this model, and you don't need people for that, and you don't need people for doing that at any stage. I'm Nadezhda Kusakina from Sberbank, and here's my question. Why did you not take into assumption a random forest method? Studies tell us that this machine learning method is quite prospective to analyze network traffic. Thank you for the question. Well, we don't have data marked, so we used a different model instead called isolation forest. It has similar features as a random forest, but it can cope with unmarked data. Alexander Yumakov is from Umani, detecting abnormal events in real time, and yet you retrain the model once a day with a one-day lag. And you said that other methods were not working. For how long? For not working for more than one day? Let me clarify. We launched that once a day, and it could be working for an hour, 30 minutes, but in parallel, we have a model to which we send these batches of events in real time. And we send them there. Less than a minute passes, and we get the result. Thank you for your report. I'm Denis Barilov, and here's a question. Somewhere, people use different resources which could be blocked at any time in Russia, and people use VPN. So they use VPN or Tor. Will this be affecting the traffic? Will they be affecting anomalies? I think they will affect, but seems like that today it's just a matter of separate investigation, I would say. I'm talking about the precision of this model. You say that these false positives levels contains here. What's false positive? What's false negative level? The false positive and false negative level ultimately was measured by the customer's feedback. So we launched the work of our system from the customer. We collected these incidents, they were resolved, and they were closed as false positives, or they worked with them again. So thus we measured the level of approximately 50%, and we added some anomalies, some non-typical events in order to evaluate our model in vitro.
Что у нас нету false negative, а false positive меньше, чем 50%. К сожалению, прямо точную цифру я сейчас...
Negatives. I'm not going to say anything more precisely, but I hope I answered your question. Another question. Hello. You measured this false positives count, legitimate scanning, etc. How could the model detect non-legitimate scanning if this model was trained as legitimate further on? The model had understood that scanning from this particular host was legitimate, but scanning from a different host was considered to be a separate event and could be identified. So again, things said about reverse shells from the legitimate host creates danger to the non-legitimate scan, and the system identifies this as the legitimate scan, right? It is possible with the SVM, but it did not reduce to just one model. Such things can be identified with the isolation forest approach, and we also take this feedback with some probability. So seems like that some of the events were left as false positive and nothing was changed in the model. Seems like it was addressed from the host which scans specific addresses. They did not recur, but if they recurred and recurred as more noticeable, they could be tracked down as anomalies. Thank you. Thank you. I'm Ruslan, and I have a question. Each day we infer a new model. The validation is required. So, like for example, yesterday we started getting our 1000 RPS traffic, and we keep on sending it so the model trains with it, and then we do something very similar but non-legitimate, and we'll be pinging, and the next day we'll be sending something similar to the same IP, and the model will consider it to be a legitimate thing. So that's the validation problem. How did you resolve this validation or human-in-the-loop problem? At first it looks safe. We've seen such situations a number of times, just like where you showed us the case. Someone starts pinging and we start getting an incident for that. Then, indeed, these events go to the selection, and if this selection is closed as false positive, they will not be sent there anymore. So in this case, it really all depends on the solution. That's as far as the SVM model goes. It closes the incident. They continue this discussion without the microphone, and she's answering to this question. This is going to be grouped with all of the 10,000 events. Next question from Alexander. How does this model take this infrastructure into account? If the service breaks down, how can it process the infrastructure status? Correct me if I'm wrong, whether I understood it right. There was some kind of the interaction occurring, then it stopped, and then it's going to be reinstated, and it will be evaluated as new. For the first time, it will be identified as an anomaly, and an incident will be created, which will be considered and closed. Well, we have multiple data centers and a lot of available services, so it seems like we will have to process these false events each day. Answer. What I mean here is that such events that recur after a long period of silence should be identified at the normal behavior of traffic. Your examples may recur as new, but they will not be standing out. So there will be no such a flow of events. And we did try it and we did test it. Some non-typical events would get through, of course. Next question, I'm Denis Kiryanov, and here's the question. Could you differentiate the traffic from miners or other non-conventional sources with lots and lots of requests, which cannot be considered as an anomaly? Answer. We started detecting such events and we put them later into a statistical model, and it coped with such events quite well. Hello, Alexei Zhurin. Two questions. Correct me if I'm wrong. You didn't use neural network algorithms and machine learning because it took too long for them to work. And you said that the lag was about 1 day. And about the resolution about some kind of traffic was momentarily instant. What would be the problem using neural networks and deep machine learning? And did you take a look into the body of the packets or you only chose the parameters identical for the majority of scenarios in businesses, in business networks? We did not take into account neural networks yet. We'll do it in the future. We're planning on doing that. We did not start with them because when we started resolving that task, it turned out to be quite complicated for us. So we wanted to start with far more transparent methods. Apart from that, neural networks take much longer to work. So that's why we decided to put them on hold. As far as taking a deeper look into packets, we didn't do that. We tried to take universal features and characteristics similar to different companies. Let our speaker go, and let's end up with these questions, enough questions. Valentina is going to be available here, so now we need to select 2 interesting questions. The time is up. Well, Valentina is answering. Too many interesting questions, but the first question was about this host. A white T-shirt, a black T-shirt? I think a black T-shirt goes there. And who was given this piece of advice about the host? Okay, and the second best question. And I need to thank people for complicated questions. This young man, Alexander, is sitting here in the first row. But I wouldn't want to offend anyone. I liked all of your questions. Thank you very much for joining me here, and thank you for your questions. Next speaker will be here at 1 p.m. Thank you.